Fine. Today, first of all, I'll teach you use of offset list in EIGRP. So in EIGRP, remember that we cannot use offset list to perform route filtering like we use this offset list in RIP. In RIP, I taught you that how can you use offset list to perform route filtering. But in EIGRP, it is not possible to use this offset list to perform just route filtering. Here in EIGRP, you can use this offset list just to manipulate your path selection in EIGRP. Like for an example, for R5 might be the best path to reach the loopback of R1. I mean the lane network of R1. Its best path is via R4. With using offset list, you can make it via R3 or via R2. Sorry. Are you getting my point or not? Let's say for R5, the best path to reach the loopback of R1 is via R4. But if he wants to make it via R3, then we can also use offset list. I mean, here in EIGRP, you will be using this offset list just to manipulate your path selection. You can also use this offset list in another way as well, like just to perform equal cost load balancing. Just to perform equal cost load balancing, because sometimes what happens, let's say that let's take an example again of R5. R5 is receiving the loopback of R1 from its neighbors R4 as well as R3, but by default its best path is via R4 only. So it is not going to install route via R3 in its routing table due to metric only, right? Because via R4 it is having its successor and via R3 it is having feasible successor. So without using variance command, it's not possible to install your feasible successor in your router's routing table. Is it possible? No. But with using with having or with configuring offset list, you can achieve it. What can you do? Actually, with using offset list, again you will be adding your metric. You cannot reduce your metric, but you can add some more metric with using offset list, because the meaning by offset is what? Just to adding. So you can add metric by using offset list here in EIGRP. So you do one thing, because for R5, I mean in perspective of R5, the total metric to reach the loopback of R1 is lower via R4 rather than via R3. So do one thing, with using offset list, increase its metric via R4, so that the metric via R4 as well as via R3 to reach the loopback of R1, to reach the loopback of R1, the metric will become same via R4 as well as via R3. Once the metric will become same, will become common to reach the loopback of R1 via R3 as well as via R4, then your router R5 will start to perform equal cost load balancing. I hope that you have understood it now. So with using offset list, you can achieve equal cost load balancing. The second task, you can also manipulate your best path selection. Might be that the best path to reach, I mean from R5, the best path to reach R1 is via R4, but you want to reach it via R3. You do one thing, with using offset list, just increase its metric via R4, so that the metric via R4 will become higher than via R3. Once the metric via R4 to reach loopback of R1 will become higher than via R3, then definitely for R5 its best path will become via R3. This is the only uses of offset list. Again, there is very simple definition for offset list, just to increase your metric. Now you know very well that why would you require to increase your metric, right? So accordingly you will take decision, accordingly you can configure offset list. But here remember that you cannot perform filtering with the help of offset list. Let's do it now. Let's move on R5. Let's check for the loopback of R1. Show IP route 150.1.0. Check it out. So its best path is via 45.4. Now let's check its topology table as well. Show IP EIGRP topology 150.1.1.0. Then its subnet mask. You will see that it can reach it via, that's fine, via R4. It can also reach it via R3, and as well as it can also reach it via R2. So might be via R4 it's having its successor, via R3 it is having feasible successor, whereas via R2 it is having possible path. Now what I want, that for R5 its best path to reach the loopback of R1 must be via R3 only. It should not be via R4. So let's make it now. We know very well the total metric to reach this loopback of R1 via R4 is 232 3456, whereas via R3 it is 2374656. So what's the difference? We can use calculator to calculate this difference, right? So higher value is what? 2374656 minus 232 and then 34. So it is 51200. So let's do one thing. Let's add 61200 via R4. Let's add, because you have to add some more metric, right? If you add only 51200, then it will become same and it will start to perform equal cost. But if you add 51201, then its best path will become via R3. Let's do it now. To configure offset list, rules are still same as RIP. There is no difference in the configuration of offset list in RIP and EIGRP, right? The configuration is same in RIP as well as in EIGRP. So first of all, you have to create an access list. One commit 150.1.1.0, then its wildcard mask, and then go to router EIGRP 100 and then say offset list. Then it will ask about your ACL, it was 1. Then it will ask about in or out. So of course this prefix is what? Incoming prefix. It's not going out. However, in EIGRP also you can configure your offset list in both directions. You can also configure it in outbound direction as well. So offset list 1 in, and then you can add that metric here, which is 51201. 51201. Now remember, do not add or do not press enter here, because if you press enter here, this, and in that case this offset list will be applied on all interfaces for their incoming updates. So because you wanted to add it via R4 only, so you have to apply this offset list only on serial 0/1. So move on R5 and apply it only on serial 0/1. Now you will see that for R5 its best path will become via R3 automatically rather than via R4.
अपने यहाँ इन पे लगा दूसरे इन पे ना आउट पे लगा ये पॉलिसी तो कौन सा पॉलिसी फॉर एग्जांपल मैंने रिप की बात कर रहा हूँ तो रिप में मैंने एक साइड में ऑफसेट लिस्ट में जो
fine guys, so now you can see that on R5 its best path have become via R3, you see, and if you trace route it 150.1.1.1 definitely will go via R3. So in this way you can modify your best path selection with using offset list. Now if you wanted to perform equal cost load balancing, because we knew that the difference in between their metric is 51200, so you do one thing, because we knew that the metric to reach the loopback of R1 via R4 is lower than via R3. So we just need to add 51200 metric via R4. So do not add 51201, right? So let's move again back on R5, do show history, as here I added how much? 51201. So remove it and in place of 1 make it 0. So now you will see that via both neighbors this metric will become same, and now it will start to perform equal cost load balancing. So remember that unequal cost load balancing can be achieved with the help of variance value. You cannot achieve unequal cost load balancing with using offset list. With using offset list you can achieve only and only equal cost load balancing, because the meaning by equal cost load balancing is what? Like it will perform load balancing equally, right? It will perform load balancing equally. Whereas in case of unequal cost load balancing means load balancing will be done unequally. Like in previous class I told you that okay, load balancing should be done in ratio of 1:2. So that is not possible to achieve in case of or with the help of offset list. I mean without using variance you cannot achieve unequal cost load balancing. So might be that you have heard it before that with using offset list we can also achieve unequal cost load balancing, but it is not possible to achieve unequal cost load balancing without using variance. So this time again you will see that what is the best path to reach the loopback of R1. So this time you can see that via R4 as well as via R3 it's having equal metric, that is why it is performing now equal cost load balancing. Show IP route you can see here, and for the loopback of R1 you will see that it is performing equal cost load balancing. Even you can also perform trace route here 150.1.1. you will see that traffic is going in both direction, in the direction of R4 as well as in the direction of R3, and then finally it is reaching R1. Have you understood it now? Tell me. So in this way you can use offset list in EIGRP. But again I am repeating my line that in RIP it was also possible to perform route filtering with using offset list, but here in EIGRP it is not possible to perform route filtering with using offset list. Fine. After going through this offset list, I've removed this offset list from here, and again for R5 its best path will become via R4 only. You see it have become now. To reach the loopback of R1 its best path is now via R4 only. Fine. Let's talk about administrative distance values in EIGRP now. You know very well that in EIGRP we are having three types of different AD values for different types of routes. For internal prefixes it's by default 90, for external prefixes by default it is 170, and for summary addresses for summary routes it is by default 5. I'll teach you all these things, that why is it necessary to configure its AD value as 5 for its summary address. I'll teach you, don't worry. But right now I'll simply show you that how to modify, how to manipulate your administrative distance value, right? How to change your administrative distance value and how to manipulate your best path selection in EIGRP with using administrative distance value. And remember that AD value comes before than metric. Metric will always be compared if your AD value is common. So this time for R5 you see that for R5 its best path to reach the loopback of R1 is via R4. We want to make it via R3, and we know very well that via R3 as well as via R4 its AD value is what? 90. So you do one thing for this special, for this prefix only, change your administrative distance value and configure it higher than 90, so that the AD value to reach this prefix will become higher via R4 than via R3, because via R3 still its administrative distance value will remain as 90. So make it either 91 via R4 or make it 89 lower than 90 via R3. So you can also manipulate it in this manner. To achieve it, what can we do? And also it will also and also we will prove that this AD value will take place first than metric. It will compare administrative distance value first rather than comparing metric. So on R5 you do one thing, because this time I just wanted to change it for 150.1.0. so do show IP access list. First of all let me check this ACL. Yeah, ACL is already there, right? Now you do one thing, router EIGRP 100, you know very well distance. Here we are having two different things. One, like distance EIGRP, then it will ask for internal routes which is by default 90, you can make it 70, and then it is asking for external prefixes, let's make it 150, and then you can press enter. Now what will happen, that for this router for all prefixes, it's for all internal prefixes AD value would become 70, for all external prefixes its AD value would become 150. And if you don't want to change its AD value for external prefixes, then leave it as default, which is by default 170. So you can also configure this command, but it is mandatory, it is compulsory in this command to specify the AD values for both types of prefixes, for internal as well as for external. Otherwise your command, sorry, here your command will remain incomplete if you do not specify both AD values, AD values for both type of routes. Fine. Then after you do one thing, this was that how can you manipulate your administrative distance values for all internal prefixes as well as for all external prefixes. Rather than changing your AD value for all internal prefixes as well as external prefixes, you can also modify administrative distance value for a particular prefix as well, from a particular neighbor as well. Means per prefix per neighbor. You can modify your administrative distance value per prefix per neighbor. So let's say distance, let's say I wanted to configure it as 65, or sorry, you can make it 91 as well via R4. So you do one thing, you said distance 91, now it is asking about its source. So from where you are getting all these prefixes, 155.1.45.4, because R4 is having this IP address. So we were having this prefix, we were receiving that lane network of R1 from R4 with lower metric. Now I'm going to manipulate this path selection by modifying its AD value. So this time say distance 91 155.1.45.4, because we are receiving it from this neighbor only. Then it is asking for wildcard mask. So because we are having only this dedicated neighbor, so I will specify my wildcard mask as 000, and then after you see that it is asking for ACL. Even you can also press enter here without specifying your ACL as well. So if you do not specify your ACL, in that case it will change its AD value for all those prefixes which are coming from this particular neighbor. But I just wanted to change its AD value only for that specific prefix, which was the lane of R1. And the lane of R1 is what? I have already called that lane in ACL1. So here I have called that ACL1 now. So what will happen, what is the meaning of this command? That it will configure its AD value as 91 whenever it will receive prefixes from this particular neighbor which will match with this ACL. So it will change its AD value only for those prefixes which are matching with this ACL. So now let me show you show IP route for 150.1.1.0, and now you can see that this time its best path have become via, tell me. So before metric it is comparing their AD values, is not it? And to check your configuration of AD value, you see run this command show IP protocols, and you will see that distance by default is 90 for internal prefixes, for external it is 170, but when source is this and ACL is this one, in that case its distance value will become 91. So I hope that now you have understood it, that how to modify, how to manipulate your path selection by changing its AD value based on per prefix per neighbor. So this is that how can you manipulate your path selection by modifying administrative distance value. So is there any problem now? If you are having any problem in this command or in this concept, please let me know. Otherwise we can go for next topic now. It's same as RIP. There is no single difference in modifying its AD value or in manipulation of best path selection in between RIP and EIGRP with using administrative distance values. And also you can filter it. If you want to filter it, then also you can achieve it. Like for an example, this time if you move on switch 4, you will find all prefixes coming here, right? Let's say that I want to filter any specific prefix. Let's say that I want to filter the loopback coming from switch 3, which is 150.1.9.0. So you do one thing, create another access list 10, permit 150.1.0, sorry 9.0, and then it's wildcard mask, and then say router EIGRP 100 distance is 255, and then it will ask about your source. So source is going to be 108.8 because you are getting all prefixes coming from switch 2, and then after you can specify its wildcard mask, and then after you can also specify your ACL, which was 10. So this time it will configure its AD value as 255 for those prefixes which are matching with this ACL and coming from this particular neighbor. Show IP route, let me show you once again its routing table, and this time you must not be able to get the loopback of switch 3. Is there? 9.0? Of course no. And if it is not there, and if you try to communicate with 150.1.9.9 now, so definitely you cannot communicate with this loopback of switch 3 because this route is not available in our router's routing table. So now router EIGRP 100, and just go and remove this command once again. So I have taught you that how to modify, how to manipulate your best path selection with using administrative distance value, and also how to perform route filtering with using administrative distance value. So if you are having any problem related to administrative distance value or use of, with use of administrative distance value in EIGRP, please let me know. Understood or not? Fine. So this is the uses of administrative distance value. Now let's talk about summarization as well. You can also perform summarization in EIGRP, router EIGRP 100. Let's remove this previous command from here. And you know very well that because EIGRP also comes under distance vector routing protocol, and as I said earlier on, that in all distance vector routing protocol you can configure summary address anywhere in the network on any router. So same as RIP, in EIGRP also you can configure summarization on any router. So once again, let's do one thing. Create some loopbacks on switch 3 in range of 90.1.0/24 to 90.1.5.0/24. So you do one thing, move on switch 3, create loopback 1, IP address 90.1.1. Even I will create 7 loopbacks. Fine. And then you will require to advertise them into EIGRP, and command will be 90.1.0.0, and I hope that you can understand it very easily. The meaning of this command 7.255, it means that EIGRP will get enabled only for these networks, not for any other. Like if any loopback is having 90.1.8.1, will it be really possible to enable EIGRP with using this command on that interface? Of course no. EIGRP will not get enabled on that loopback which is having an IP address like 90.1.8.1, because 90.1.8.1 will not come under this range. Have you understood it or not? So after running this command, let me show you IP EIGRP interfaces, and at that moment, now in the result of this you will come to know that okay, EIGRP has enabled on all these loopback interfaces. And now on switch 4 you must be able to see all those prefixes, and all of them are coming individually, right? So if you want to reduce the total number of routes available in your router's routing table, then you can perform summarization. As I said earlier on, that in EIGRP it is possible to configure summarization on any router, but here it is always recommended. It is always recommended to configure summarization near to source. So where is our source? Of course switch 3, near to source. Who is originating all these prefixes? Who is advertising all these prefixes? Of course switch 3. So it will be better for you, or it will be best place to configure summarization in this network, right? However, it is not mandatory. Even you can also configure it on R5 F0/0, because R5 is also advertising all these prefixes out from F0/0 individually. So you can also configure summarization on R5's F0/0. Or you do one thing, configure the summarization on R3's S0/0, R2's S0/0, as well as R6 F0/0, so that whenever R6 R3 and R2 will advertise all these prefixes towards their neighbor, then also they will give it in summary form. I mean, they will also advertise only and only summary address, right? Or do one thing, configure summarization on switch 1's F0 by 1 or F0 by as well as F0 by 0, so that now switch 1 will also advertise only and only summary address. But now you have seen it, you have observed it, that if we are configuring summarization on any other router rather than configuring it on its advertising router, might be we will require to configure multiple summary command on multiple interfaces. Is not it? Like if you configure it on switch 1, then of course you have to configure it on FA0 by 0 as well as FA0 by 1. And if you do not follow this rule, then your entire data flow will get changed. Because let's say that you have configured this summary address only on FA0 by 0, you didn't configure it on FA0 by 0. So whenever switch 1 will advertise all these prefixes, all of them will go individually out from FA0 by 0, but out from FA0 by 1 it will advertise only and only summary address. So for all other routers, their best path will become via R6 only. You know why? Because via R6 they will keep on to receive all these prefixes individually on /24, whereas via R3 they will be receiving it on /21. I mean, they will be receiving it as a summary address, right? And based on longest prefix match, because before metric and AD value they will compare their longest prefix match. So based on longest prefix match for all routers, for all LAN users, their best path to reach all these 90s prefixes will become via R6. Are you getting my point or not? So whenever you are going to configure summarization in your network, please be careful, because if you do not configure it carefully, it might be that your entire data flow will get changed. Even you can check it out, like from switch 4 you can trace route 90.1.1.1. fine, it is going through the best path, like switch 2, R5, R3, switch 1 and finally switch 3. Means it is going in this way: switch 4, switch 2, R5, R3 and then switch 1 and finally switch 3. But if you configure summarization on switch 1 0 by 1, let me configure it on switch 1 0 by 1. IP summary address EIGRP 100 and then 90.1.0.0.245.245.248.0. That's fine. So this time this switch 1 will advertise only and only summary address out from this interface. And now you will see that for all 90s prefixes, the best path from switch 4, I mean you can trace out it from switch 4, you will see that now it is going via R5 and then R4, then R6, switch 1 and then finally switch 3. Is not it? You can trace route any 90s raised prefix like 90.1.2.1 as well. So for all 90s prefixes, its best path will become via R6. So that's why I said that if you are going to configure summarization, please be careful before going to configure your summarization, because due to summary only, due to summarization, your entire data flow can get changed. So please do it carefully, configure it carefully. Fine, I have removed it now once again. So now I hope that you have understood that how this summarization is critical for your network. Let's move again on switch 3, and this time I will be configuring the summary address on switch 3 itself, because switch 3 is advertising all these prefixes individually, right? So let's do configuration only on FA0 by 0 of switch 3. So move on switch 3 is FA0 by 0. IP summary address EIGRP 100 and then summary address for all these prefixes 90.1.0.0, 245.245.248.0. And in EIGRP, as I said, that whenever there will be any summary address, whether it was configured by you or it was generated by your device automatically, it will always put that entry towards null interface in its local routing table. So let me show you on switch 3 itself for all these 90s prefixes. Null 0 is not it. And for this prefix you will also find its AD value as 5. So IP route 90.1.0.0 245.245.248.0 was that. it does not mean that this AD value 5 will remain on all other devices as well. No. If you move on switch 1, because switch 1 is receiving this prefix as internal prefix, and for all internal prefixes by default AD value is what? 90. So remember that AD value will be 5 for summary address, but only for that router, only on that device where you configured that summary address. So here you can see that its AD value is what? 90. I will also teach you that why is it really necessary to configure its AD value as 5 for summary address on that device where you configured your summarization. It is mandatory actually. It's not that configuring its AD value as 5 without any reason. No, there are some technical reasons so that it is configuring its AD value as 5 for that summary address which you configured on device. Fine. So this is that how can you reduce total number of routes in EIGRP by using summarization. So previously, as you saw that on switch 4 we were getting all prefixes individually in the series of 90s networks, 90s prefixes, but now you are receiving only and only summary address. Then after, let's do one more thing over here on switch 3. We can also do one thing. We can remove it from here, and I will try to configure it in different manner, now, so that we can achieve something different here with using summarization. Now, actually, I wanted to configure summarization, but along with summarization, what I want that for 90.1.1.5.0/24 only for this prefix, right? And I don't have the console access of this switch 3, so we cannot configure summarization on switch 3 now. Vinith, we do not have the access of console of switch 3. We are having the access of switch 1 only. So you have to configure summarization on switch 3. Sorry, switch 1. You are having the console of switch 1 only, not switch 3. So because all these 90s prefixes are coming individually, are coming separately from switch 3 to switch 1, and then further switch 1 is advertising them towards all others, right? Fine, that's true. But now this time you are required to configure summarization on switch 1, right? So you will configure summary address on its FA0/0 as well as FA0/1. But along with this summarization, what I want that for this specific prefix 90.1.5.0 for all routers, preferred path must be via R6 only. Are you getting my point? You must configure summary address for all prefixes on switch 1, but also make sure that only for this specific prefix 90.1.5.0 the preferred path for all other routers lane users must be via R6. How can you achieve it? For this we are having here leak map. To achieve these types of tasks we are having leak map. What can we do? We can configure summary address for all prefixes on FA0/0 as well as on FA0/1. Of course, summary address summarization will be done successfully, right? And this 90.1.5.0 will also be part of that summary address. But along with configuration of summary address on FA0/0, what can you do? You can configure leak map, and in leak map you can leak this prefix only individually on /24 itself. You can leak this prefix particularly along with your summary address. So what will happen now that for all other routers based on longest prefix match, the best path to reach this subnetwork 90.1.5.0 will always be via R6. And in case if R6 goes down, then these old routers will still keep on to receive this 90.1.5.0's information in the form of summary address via R3, because here on FA0/1 also you will configure summary address, is not it? So in this way you can manipulate your path selection with using summarization. Along with summarization you can use leak map just to perform path manipulation. This is the only uses of leak map in EIGRP. Again, I'm gonna to teach you this method or this I'm just repeating my previous lines. If someone asks you to configure summarization on switch 1 for all 90s prefixes. Of course, we will configure it on FA0 by 1 and 0 by 0, and then switch 1 will advertise only and only summary address towards all other routers in this diagram. Is not it? But along with this, we were also having another requirement that only for 90.1.5.0 subnetwork, from all other routers in this EIGRP domain, the preferred path must be via R6 only. To achieve that, here we can use link map, and let me configure it now. So right now switch 4 is receiving all prefixes individually here. Fine. Do one thing, move on switch 1. On switch 1's FA0 by 1. Say IP summary address EIGRP 100 and then 90.1.0.0 to 245.248.0. Fine. Then just come outside, you have to configure summary address on FA0 by 0, but along with that you have to configure link map. So in link map you will call that prefix to whom you want to advertise individually. To whom you want to advertise individually along with summary address. So you do one thing, say access list 10 permit, just match your that individual prefix only. So that was 90.1.5.0. Create one route map with the name of permit. Match IP address is what? 10, because I created ACL with the number 10. Then route, then here you do one thing, go to interface FA0 by 0, IP summary address EIGRP 100, and it was 90.1.0.0 to 248.248.0, and then link map, and link map name is what? Link. So this time you have configured the summarization, the summary address on both interfaces of this switch 1 on FA0 by 1 as well as 0 by 0. On FA0 by 1 I didn't configure any link map, but on FA0 by 0 I configured the summary address along with link map. So you do one thing, again move on switch 4, you will see that it will be receiving summary address as well as this 90.1.5.0 individually, right? So now you do one thing, trace route 90.1.1, you are going via switch 2 R5 R3 switch 1 and then switch 3. But if you trace route 90.1.5.1, you have to go through via it's not it, so it is going via R6 only to reach this destination actually. So in this way you can perform path manipulation with using summarization. So in summarization you can also use link map. Apart from it, let me show you some other things as well. Like, let's move again on switch 1 and remove this command from here, from FA0 by 1 also remove this command, you understand? So again I have removed this summarization. So this R1 is gonna to receive all these 90s prefixes. See, where is this R1? This is R1 has to receive all these 90s prefixes, is not it? And by default it will be receiving only and only, by default it will receive all prefixes from 90s trees individually, because we have not configured summarization on any router, right? And by default its best path to reach all these 90s prefixes is via R6. Fine. Now with using summarization only, you have to achieve one task. You have to perform one task, that for first three prefixes only, 90.1.0.0/24, 90.1.1.0/24, 2.0/24, 3.0. But out from these four subnets we are having only three subnets here, 1.0, 2.0, 3.0. For first three prefixes, its best path should be, hello, are you getting a point or not? Its best path should be via R3. Do one thing, on R6 FA0/0 configure summarization for first three prefixes. Are you getting my point or not? Configure summarization for first three prefixes only, like for 90.1.0/24, 90.1.2.0/24, 90.1.3.0/24. Configure summary address for these three prefixes on R6 FA0/0. So based on, because R1 will still keep on to receive all these prefixes coming from R3 individually on /24. So based on longest prefix match for R1, its best path to reach all these 90 prefixes will become via R3. And in case if R3 goes down, then definitely of course R1 will keep on to receive this summary address via R6. So you do one thing, move on R6 now. On its FA0/0 IP summary address EIGRP 100, then 90.1.0.0 245 and then tell me, is not it? In this range now you will see that first three prefixes will come. Now you do one thing, move on R1 once again, check for 90s prefixes. First three prefixes have learnt via. So if you trace route 150.1, sorry, if you trace route 90.1.1, sorry, you are going via R3. If you trace route 4.1, then definitely you will go via R6. Have you understood it or not? Even in case if R3 goes down, on R3 we can shut down, or on R1 itself we can shut down this S0/1. Move on R1, go to S0/1 and shut it down. Show IP route. If still it is receiving that summary address, oh, you see, but these are coming individually via, because R3 is giving it to R5 and R5 is giving it to, and then finally R4 is giving it to R1. But again you have learned it, right, that R1 is still having all these prefixes, right? You do one thing, move on R4 and shut down its FA0/1 as well for some time only. Again move on R1, it will break its neighborship with R4, but still you will see that it will keep on to receive the summary address for first three prefixes via R6. Swipe it out, and now if you say trace route 90.1.1, of course you will go via R6. Is not it? Now in case if its serial 0/1 comes up, then again its best path will become via R3 only. So I hope that now you have understood the uses of summarization in EIGRP. With using summarization, of course you are reducing to total number of routes available in your router's routing table. Along with that, you can also perform path manipulation. Understood? Again, if you trace route it, you will see that you are going via R3. Fine. Now let me show you some problems due to summarization in EIGRP. And let me prove it. Let me make you understand that why do we have its AD value as 5 for that summary address entry in its local routing table towards null interface, right? I will show you each and everything. See, this time do one thing, move on R6, FA 0 by 0, and then remove this summary address from here. And again you will see that R1 will start to receive all these prefixes coming individually from R6 as well as from R3. But based on metric, for R1 its best path will become via R6 only, as you can see here on R3 as well. Sorry, on R1. Its best path to reach all 90s prefixes must be via R6 only. Fine. Good. Now you decided that okay, for all 90s prefixes the best path should be via R3 only. Let's say there is some requirement, so that according to those requirements for all 90s prefixes best path from R1 should be via R3, and you have to achieve it with using summarization only. You are not allowed to use any other method, because you can also achieve it by modifying its AD value, by using offset list as well. But here you are allowed to use only summarization. So you decided that okay, let's do one thing, let's configure summarization for all prefixes on R6 FA 0 by 0. Are you getting my point or not? So now you moved on R6 on FA 0 by 0 and IP summary address EIGRP 190.1.0.0 to 45255.248.0. Now R6, on R6 we have configured summarization or summary address on its FA 0 by 0. Now I will show you that for R1 its best path will be via. Are you getting my point or not? So you see, it have received the summary address coming from 6, but also it have learnt all those prefixes coming from its neighbors individually on /24. Any problem? Fine. So its best path will become via R3 now. For all prefixes belongs to 90s range. Done. Because this R1 has learnt this summary address from R6 only, it have not learnt it. I mean, it didn't learnt it from R3. So because it didn't learn from R3 this summary address, so definitely R1 will advertise this prefix information towards R3, is not it? So now R3 must learn this summary address from R1. Let me show you. Because it is this is the behavior of distance vector routing protocol, that if you are having any best path information, then you have to advertise it towards your neighbor. So you can see here that it is receiving the summary address from R1. Guys, try to understand it. R3 has learned it via R1. R1 got it from R6. Then R3 can also advertise it in the direction of switch 1. Fine. Let's move on switch 1 now. Switch 1 must also receive it, must also accept it. You see, switch 1 will accept it via R3 because it received it from R3. Then switch 1 can give it back to switch 3. Is not it? Can give it back to what? Lost?
It will not.
Why? Why will it not give it to our switch 3? Because switch 1 received it from R3, and according to the distance vector routing protocol, it must advertise its best path information to switch 3 now. So you can move on switch 3.
We have to create summary switch 1 or R6?
We configured on R6.
In case of switch 1 it won't.
Of course, if you would have configured summarization on switch 1, then of course in that case it will never accept this summary address. It will never install it via R3. But this time, because we didn't configure it on switch 1, that's what I wanted to show you, that if you configure the summary address on an unappropriate place, on unappropriate router, it can cause a big problem in your network. Now you will see switch 1 has again learnt it via R3, and then switch 1 can give it back to switch 3. You must receive that summary address coming from. However, all these prefixes are directly connected with this router, but still for its own prefixes it is receiving summary address. And if switch 1 have given it back to switch 3, it means switch 1 will also advertise it in the direction of R6 as well. Are you getting my point or not? Switch 1 will also advertise it in the direction of R6 as well. Guys, try to understand. So if it advertise it in the direction of R6, now R6 will receive it. But it didn't install the summary address in its routing table via, tell me, switch 1. You know why? Switch 1 is giving this update to R6, but R6 will not accept it. You know why? Because it is also having, R6 is also having same prefix
because of AD.
with lower AD value. Because in received prefix, because see, this R6 is also receiving the same prefix coming from switch 1, but it is not going to accept that prefix and is not going to install that inside its own routing table due to AD value. Because for this prefix its AD value is what? 5. And for received prefix its AD value was 90. So you do one thing, make it 91 for null. For its own entry, make its AD value as 91. We can change it, right? As you can see, show IP route 90.1.0, sorry, 90.1.0.0 245.248.0. AD value is 5. Interface FA0 by 0, and then go to some here and summary address along with, just remove it and then say IP summary address EIGRP 100 90.1.0.0 245.248.0, and then you can define your AD value and make it 91. Say wow. Understood? This time it has accepted that prefix coming from switch 1, because for its own, for previous entry, previously it was having its AD value as 5 for that null entry, right? But this time we have configured it as 91. So based on, because prefix length is common, and then it will compare, tell me, AD value. So based on AD value, it have preferred it via, it have installed this summary address via switch 1 now, and then R6 will keep on to give this summary address information to R1, as you can move on R1 as well. Show IP route, let me show you. It will keep this default, this summary address coming from and then it will give it to R3. R3 will give it to, and switch 1 is giving it to switch 3 as well as R6, and then R6 is giving it back to R1. Now, fine. It has happened in your network now. Let's assume it. And any one of the loopback from 90s prefixes, hello, from 90s prefixes, let's say that any one of the loopback has gone down. Any one of the network, subnetwork has gone down on switch 3. Loopback 1 shut down, but there will not be any problem. You know why? Because the switch 3 is gonna switch 3 will not advertise this prefix to switch 1, but switch 3 is still advertising all other prefixes rather than 90.1.1.0/24, right? Apart from that prefix, it is still advertising all other prefixes. So switch 3 will give all those prefixes to switch 1. Switch 1 is giving it to R6, but on R6 you configure summary address. But if any one of the prefix, any one of the subnet from the summary address has gone down, it does not mean that your router will stop to originate summary address. It does not mean that your router will stop to generate summary address. Your router will still keep on to advertise that summary address, right? So R6 will still keep on to advertise that summary address in the direction of R1. R1 will advertise it in the direction of R3. R3 will advertise it in the direction of switch 1, and switch 1 will advertise it in the direction of R6. Now, from R1, as you can see that it is receiving the summary address coming from R6. Fine. Now if you trace route 90.1.1, so because it is receiving this prefix from R6, so it will give this data to the R6. Now R6 is not having any entry towards null 0. It received this prefix from switch 1, so it will give it to switch 1, and switch 1 received it from R3, it will give it to R3. R3 received it from R1, it will give it back to R1, and then R1 will give it to R6. So let me show you now. You see, there is a there is a routing loop now. Because sometimes this route is existing there, sometimes this route is not there. But you can say that there is a routing loop. You know why? Because you see, it is giving to R6. R6 has given it to, and then switch 1 further have given it to, and then it is coming back to. Have you understood it or not? Tell me. So I hope that now you have understood that if you change your AD value for summary address, then there can be a big problem. Your entire network, your network can even, of course there will be a big problem if you do some misconfiguration along with your summarization. So this is that how can you see that, okay, in EIGRP also there can be a routing loop if you do not configure your AD value as 5 for your summary address. Have you understood it or not? Fine. Let's move again on R6 and let's change its AD value. Make it once again. Five. And because this time you have configured its AD value as 5 once again, so you will see that it will install that prefix, that summary address towards null 0 in its local routing table. And now we can move on R1. Still that loopback is down 90.1.1.1, right? But this time because it is receiving this summary address coming from R6, so it will advertise, it will transmit data in the direction of R6, and because R6 do not have any individual prefix for reaching 90.1.1.0/24 network, right? But it was having a summary address going towards, pointing out null interface. So this time R6 have transmitted all this traffic towards null interface and it has been dropped. That is why there is no routing loop now. So I hope that you have understood that in EIGRP, why do we have AD value as 5 for summary address, right? And why do we have this feature in EIGRP that wherever you will configure summarization, it will always put that entry towards null 0 interface as well. Because if that entry is not there, then in that case there can be a routing loop, and we have seen it. We saw that how can a routing loop occur in your network if your routers do not put entry towards null 0 interface in their routing table. Have you understood it or not? Tell me. Fine. So this is that how can we modify AD value for summary address, and what will be an impact. AD value? No.
नहीं जो समरी रूट है जैसे हम नल 0 के साथ होता है, नल 1 के साथ भी हो सकता है?
नहीं, कभी नहीं होता। नल 1 इंटरफेस होता ही नहीं है, नल 0 ही होता है, सिर्फ नल 0। Guys, have you understood all these topics till now, like summarization and all? the use of link map, Pushkin. Vinit, any problem? Sure. Fine. Let's again move on R6 and remove this summary address from here. And again for R1, its best part to reach all these 90s prefixes, 90s subnetworks will become via R6. Fine, let it be. But finally, now I have taught you that how to configure summarization and how to manipulate the things with using summarization. Fine. My final question is to all of you now. If you are having this type of design, this is R1, this is R2, wait, this is R2, right? This is R3. Now on R2 you are having a default route in the direction of R1. Behind R1 you are having a prefix which is 10.1.0/24. You understand? But you didn't advertise this prefix in EIGRP. Are you getting my point or not? Hello. But on R2 you have configured a default route in the direction of R1. Fine. Behind R2 you are having some prefixes. Fine. Now between R2 and R3 now EIGRP is running. Between R2 and R3, let's assume that EIGRP is running, and you decided to advertise all these prefixes into EIGRP so that R3 can learn them. And then finally you said that okay, let's configure summary address for these two prefixes, because that 10.1.0 is not coming from R1 to R2. That is why for R2 it is not possible to advertise that 10.1.1.0/24 in the direction of R3. So finally you decided that okay, let's do one thing, on this interface configure summary address, and it is 10.1.0.0/ and we can see here that 10.1.1.0 is also part of this summary address. Have you understood it or not? So because R2 was not having this 10.1.0/24, but still you can see that this 10.1.0 subnetwork have become the part of this summary address, right? So it is advertising the summary address in the direction of R3 now. So from R3 now, behind R3 you are having a user which wants to communicate with 10.1.1. So R3 is having a summary address. R3 will forward this packet in the direction of R2. Now R2 will perform routing lookup, and R2 is having a default route to reach R1, but along with this summary address it will be having this entry towards null 0 based on longest prefix match. Based on longest prefix match, this R2 will forward your packets towards null 0 interface. Is not it? Hello. However, it is having a default route by which it can reach R1's lane, but still R2 will drop your packets based on longest prefix match. Why will it use this default route to reach 10.1.0? Because in another hand it is already having this summary address towards null 0 interface. So based on routing lookup, it will take decision to forward your packets towards null 0 interface. Is not it? Now in this kind of scenario you will require to restrict EIGRP to do not install this summary address towards null 0 interface in its local routing table. So what will you do in that case? You will configure its AD value as 255. You will require to configure its AD value as 255 so that this R2 will not create this entry towards null zero interface in its local routing table, and then it will be possible for R2 to perform routing lookup, and it will be possible for this router to utilize this default route which is going in the direction of R1. So I hope that you have understood it, that in which conditions we will require to restrict EIGRP to do not install this summary address in its local routing table towards null zero interface. Have you understood it or not completely? Because there will be some few cases in which definitely you will require to restrict your EIGRP to do not install this prefix, this summary address towards null zero interface. Tell me.
This value we can get it down to R1 for that particular prefix.
In that case, there will not be any problem. In that case, you will not require to remove this entry from its routing table, this null entry, because based on longest prefix match, it will take decision and it will forward your packets in the direction of R1. If you are having this prefix available in the routing table of R2 on /24. Understood? Fine. So this is all about summarization now. We don't have anything left in summarization for EIGRP now. There is no single command to configure. I've taught you uses of leak map. You can simply leak your prefixes if it is required. I've taught you use of AD value 5. I have also taught you in which conditions you will require to change it. So finally, let's go for route filtering. And again, in EIGRP, you can perform route filtering with using only one thing, which is only and only distribute list. But within this distribute list, you can use like standard ACL, extended ACL, prefix list. But here you are also having another method to perform route filtering in EIGRP, which is route map. In RIP, it was not possible to perform route filtering with using route map, but in EIGRP definitely you can perform route filtering with using route map. So I will start it from standard ACL, then I'll go for extended ACL, and then I'll go for prefix list as well. Have I taught you in EIGRP that how to configure a static neighbor? Hello? Have I taught you that how to configure a static neighbor in EIGRP? Please go through it. Do one thing before going to perform route filtering. Let's configure static neighbors in EIGRP. As I said that in EIGRP you can also configure static neighbor, and then after configuring your neighbor statically, it will send all types of messages as unicast messages, right? It will not use any multicast address at all, but after configuring your neighbor statically. And in EIGRP it is also mandatory to configure your neighbor statically on both ends. If you have configured it on one end, then configure it on both ends. If you do not configure your neighbor statically on both ends, till that your neighborship will not come up in EIGRP. Even it was one of the requirement to form neighborship in between two routers, right? So again, I'm gonna to configure your neighbors statically here in this multi-access network in which we are having these three routers, R6, R1 and R4. I will configure this R1 as a hub, and I will take this R6 and R4 as a spoke. So again, I'm gonna to build hub and spoke topology by defining your neighbors statically here. Have you understood it or not? Hey guys, again your topology will be same as like we configured in RIP. Like I'm gonna to configure this R1 as a hub, and then R4 and R6 I'll be using them as a spoke. So R1 will be having neighborship with R4, and then also it will be having neighborship with R6 as well. So let's configure it now. So start it from R6. Router EIGRP 100, neighbor is what? 150.1.146.1, and then in EIGRP it is also mandatory to specify your exit interface, which is fast Ethernet 0/0, because this neighbor R1 is reachable from R6 out from FA 0/0 only. Sorry, it is 155. That will break neighborship. Let's move on. R4 now. Router EIGRP 100. And configure your neighbor. And exit interface is FA 0/1. Router EIGRP 100, neighbor. As well as you see that it has formed neighborship with 6, but it have not formed neighborship with R4 because I think I shut down its link. So I have to say no shutdown. You will see that now R4 will form neighborship with R1 only, but this time it have not formed neighborship with R6. Have it formed neighborship with R6 now? No, it does not have. Even you do one thing, move on R4, you can also shut down its serial 0/1, so that it will not be possible for R4 to receive any prefix coming from R5. Move on R4, show IP route. It's not receiving, it's receiving only the lane of R1. It's receiving only the lane of R1, and it is happening due to split horizon. You know why? Because R6, R1, for R1, the best path to reach all of them is via R6, because if R1 goes via R3, then it is having only serial link and its bandwidth is 1.544 Mbps and also delay is 20,000 microseconds. So for R1 to reach all other prefixes, its best path is via R6 only. So because R1 is receiving all updates coming from R6 on FA 0/0, that is why it is not possible for R1 to transmit all these updates out from FA 0/0 itself, due to a split horizon. That is why for R4 it is not possible to receive, to have any prefix available inside its own routing table. There is no route available in the routing table of R4 now, due to split horizon only. You can check it once again. So to solve this problem, what will you do? You can configure, you can disable this split horizon on R1's FA 0/0. Let me go there on R1, and you do one thing. No, say no IP split horizon EIGRP, then its AS number was 100. And this time on R4 you must have all routes available. Now all routes are coming from R1, is not it? Even if you try to trace route the loopback of R6, you are going via R1 and then coming back to, and this problem was not existing in case of RIP. Do you remember? Do you remember that in RIP it was not changing its next hop address automatically after disabling split horizon, is not it? But in EIGRP it will definitely change its next hop address. In EIGRP it will definitely change its next hop address, because by default in EIGRP there is a command next hop self which is automatically configured. In EIGRP, next hop self command is by default configured. It is a built-in feature of EIGRP. That is why when updates are coming to R1 and it is sending out from R1's FA 0/0 itself in the direction of R4, so for R4 its next hop address is coming as R1's address, and that is not good. Because we know very well that R4 can directly reach R6, but it is going to R1 and then coming back to R6. So overall delay will be increased. Are you getting my point or not? This is the problem with EIGRP. One problem we solved by disabling split horizon, because previously R4 was not receiving any single prefix from R1, right? But this time R4 have learned all prefixes coming from R1. But the problem is next hop has been changed by hub. Hub is configuring its own address as next hop address. That's the problem, because whenever you will go from R4 to R6, you have to go through the hub. You have to go through the R1. How can we solve this problem now? By disabling this next hop self feature. And in EIGRP it is possible to disable this feature. So you do one thing, move on R1 now, and on its FA0 by 0 say no IP next hop self. Sorry, EIGRP 100. Once you will configure this command now, so whenever this R1 will send all those updates out from FA0 by 0 which were received on this interface itself, is not going to change their next hop addresses. So this time whenever this R4 will receive these all prefixes, their next hop will still be 146.6 this time. As you can see now it is 146.6. So if you trace route now 150.1.6.6, you will directly go in the direction of R6 itself. You will not require to traverse R1 now. Previously it was mandatory for the users, for the lane users of R4 to traverse R1 whenever they were sending traffic to any other user in this diagram, like to the lane user of R6, to the lane user of R5, whatever it is, right? Every time it was required for R4 to traverse R1, to traverse hub, but this time it is not longer required, just due to, just because of next hop address. Have you understood it or not? Because whenever it will perform routing lookup in its routing table, its next hop address will be 146.6. So now it will definitely forward your packets in the direction of R6 only, not in the direction of R1. So I hope that now you have understood the use of no next hop self command in EIGRP, and also you must be able to understand the uses of command no split horizon as well. I hope that you have understood the concept of split horizon in EIGRP as well as the concept of next hop self. Is there any problem related to split horizon and next hop self command? Please let me know if you are having any problem with it, with any one of the command in between these two. Ask me if you are having any query related to it. Understood it completely? That what is the role of split horizon? What is the role of next hop self command? Fine. After going through these things, that what is the role of split horizon and what is the role of no next hop self, and remember I'll be using all these features of EIGRP during DMVPN, because in DMVPN, if you go to configure, if you configure EIGRP over DMVPN, you can't perform anything without using all these commands like no split horizon or no next hop self, whatever it is, right? These commands will always be required during the configuration of EIGRP over DMVPN. That's why I have covered all these topics here. Even though we are not going to configure this EIGRP over DMVPN right now, but still now we have at least understood that what is the uses of next hop self command and also what is the uses of no split horizon. Fine. Next is now route filtering. So do one thing on R4, serial 0 by 1, no shutdown, no router EIGRP 100. Say once again router EIGRP 100. Node of summary network 155.1.0.0, network 150.1.0.0. On R3, sorry, not on R3, on R1. No. First of all, remove it. 6 as well. Now please let me know if you are having any problem related to any topic which we covered till now. Otherwise, now I'm gonna to start your route filtering. Tell me. Then let's go for route filtering now.
Route filtering
Why? So this is, see, access list is there. Do show run pipe section router EIGRP. I think I have done. I'm having some initial configuration here or some pre-configuration, so I have to remove it first and then nothing. No access list. Is there any ACL now? No. So let me know, what do you want to filter out from its routing table now? All odds, all evens. Procedure is same as RIP. The uses of distribute list is same as RIP. Like you can use distribute list in both directions, in inbound as well as in outbound direction too. But remember that EIGRP is a distance vector routing protocol, so it will advertise only and only best routes information towards its neighbor. What does it mean? That if you filter some routes in outbound direction from R5, so it means they will not be available on switch 2, and if they are not available on switch 2, it means definitely they will also not be available on switch 4. So let's do one thing, move on R5 and with the help of standard ACL, filter all 90s prefixes in outbound direction going towards switch 2. So move on R5, success list 1. Let me check whether it is having any existing ACL or not. So it is already there, right? So access list 5, deny 90.1.0.0 0.0.7.245 and then say access list 5 permit. You have to permit all others and then say router EIGRP 100 distribute list. Then your standard ACL number was 5. In which direction? Out. Now if you configure this command over here only, then remember that it will be applied for all interfaces, right, of this device in their outbound direction. But if you are apply it only on FA0/0, then just call your FA0/0 only. So this time this distribute list will be applicable only for this interface for its outgoing updates only. So whenever it will advertise any 90s prefix out from this interface, it will filter them. Show IP route. However, this R5 will keep them inside its own routing table because it will keep to receive them. It will still receive them from R3 as well as from R4, but it is not going to advertise them in the direction of switch 2 now. So if you move on switch 2 this time, show IP route, let me show you. Is it there? And if switch 2 is not having those 90s prefixes, then of course they will not be available in the routing table of switch 4 as well. So it has proved that EIGRP will advertise only and only best path information towards its neighbors. And also it has proved that we can also configure distribute list in outbound direction too. So move on R5 once again, go to its FA0/0 and remove. Sorry, we have to move inside router mode, right? Router EIGRP 100 and then remove this command. And again you will see that all these 90s prefixes will be available in the routing table of switch 2 as well as switch 4. So now if you move on switch 4, if you check its routing table, you must get them. So in this way you can configure distribute list with using standard ACL, and then also you can configure standard, you can also perform route filtering with using extended ACL. And I hope that I have already explained to you that why do we require to configure route filtering with using extended ACL. So I'm not again gonna to explain all those things which we explained you during RIP. That's why I said that route filtering will not take so long time in EIGRP, because now I'm not required to explain you that how standard ACL works, how extended ACL works, in which conditions you will apply extended ACL, in which conditions you will apply prefix list, right? So we have already covered all these things. So this time I'm just gonna to implement all these things. Fine. So on switch 4, all these prefixes are coming, and this time I will filter out all these 150's prefixes coming from its neighbor switch 2 with using extended ACL. So you do one thing, access list 101 deny when these prefixes are coming from a host which is 108.8, because I want to filter them whenever they are coming, when they are coming from this particular host. Then it will ask me about destination addresses. In destination addresses you will specify to whom you wanna filter out. So 150.1.0.0, then 0.0. I think 15, or what? Will it be enough? Hello? Because your prefixes are from 1 to 9 or 10. However, 10 is directly connected, but you are having 1 to 9. So what would be your range? What would be your subnet mask to call all of them? It will be 245.245.240.0. And if you are having 240, in that case your wildcard mask will become .15, right? So this time say access list 101 permit IP any. When source is any, destination is also any. I mean all other prefixes must be allowed. So you do one thing, router EIGRP 100 distribute list 101 in which direction? In on which interface? Because switch 4 is receiving all of them on FA0 by 0. So on switch 4 apply it on FA0 by 0. And this time if you say show IP protocols, it will show you that you have configured, you have filtered your interface for EIGRP updates. I mean you have filtered all those prefixes on this interface which matches with this ACL 101. So definitely this time you must not receive any prefix which belongs to 150's range. Is there? However, it is still having 150.1.10.0, but it is directly connected. It is not received from that neighbor. So this time from this neighbor it have stopped to receive any prefix coming from the range of 150's subnetwork, 150's networks. Is not it? Because we have filtered all of them. If you are having any problem, please let me know with extended ACL. However, you will be configuring this filtering with using extended ACL in case of multi-access networks only. Like if you are receiving your routes from multiple neighbors on a single interface, right? Just like I explained in RIP as well, right? So in that case, in those conditions, you will require to configure extended ACL. Now next is what? Prefix list. Router EIGRP 100. Just remove it, and this time I'm gonna use prefix list. So which route you wanna perform, you wanna filter out from its routing table. So this time you will see that all of them are available here, 150's, 155 and all 90's prefixes. So which route you wanna filter out from its routing table with using prefix list? Tell me. 90's prefix. So just configure one prefix list here, IP prefix list CCIE deny 90.1.0.0/21 greater than, because all of them are coming on /24 itself, so you will say greater than 24, less than is also equal to 24. Say IP prefix list CCIE permit 000/0 less than equal to. Any problem? Router EIGRP 100 distribute list prefix list, and that prefix list name was, then its direction, because all these prefixes are incoming prefixes, right? You can say in. This time it will be applied for all interfaces. See, and you must not receive any single prefix belongs to 90's range. Let me show you. So there is no difference in route filtering with using standard ACL, extended ACL or prefix list in between RIP and EIGRP. Have you understood it or not? Even you could also use that gateway keyword here. Router EIGRP 100 distribute list gateway and then your prefix list, but here you will specify only and only gateway. You can also call this gateway after prefix. Let's say I said prefix was, tell me, CCIE, and then also you can call your gateway now, so that these prefixes will get filtered from these specific gateways only, which you have defined in this next prefix list. If you are using prefix list with gateway keyword, you will require to create two different prefix lists now. In one prefix list you will specify that which routes are permitted and which routes are denied. In another prefix list you will specify that which gateway is allowed, which gateway is denied, and which gateway is permitted. It is in somehow it is same as extended ACL, but it is more granular than extended ACL, because with using prefix list you can filter routes like all those prefixes which belongs to this summary address coming on prefix length /27 to 29 or whatever it is, right? I'm not going to explain all those things once again here related to prefix list, that okay, this is the reason so that you are having prefix list, this is the reason so that you will implement prefix list to perform route filtering rather than implementing standard ACL or extended ACL. So I hope that now you people have your mindset that where to implement standard ACL, where to use extended ACL, and where to use prefix list. Are you okay with all these explanation? Fine. Finally, route map. Do show or remove this command from here now. Show IP protocols. I have removed everything from here now. Show IP route. Now all routes must be available here in its routing table. Finally, it is route map. How many people are not comfortable with route map? Please